welcome to our third video, and in this video we're going to talk about ions, and we're not going to go into the full-scale detail of electronegativity and you know, how ions work with bonding just yet. We're just going to go over some really basic concepts. So let's take a look at a periodic table here, and I'm going to kind of just draw some stuff. And we have hydrogen here, and here we have, we'll do it down here, we have helium in our first row, and then if we go into our next row we have lithium, and we have beryllium, here we have boron and carbon. Actually, no, let me move that over a little bit. We have boron and carbon, nitrogen, oxygen, fluorine, and neon. So this is kind of what it looks like, and you know, you have your boxes that each one of these elements are under, you know, and so forth. So essentially what's happening here is each one of these elements is going to have some form of charge when it's an ion. And just to give you an idea, ions are just basically atoms, and this is a gross oversimplification, but atoms with some form of charge on them. Okay, so if I were to just draw an orbital here, and let's just say I'm going to draw hydrogen. This is the very first element on your periodic table, and here's an orbital, and this is, you know, the nucleus in the center here. So here's I have some neutrons. Actually, no, I don't have any neutrons in hydrogen. Let me take that back. I have a proton here. So there's my nucleus, and then here's my electron for hydrogen. Now if I were to do helium, I would draw helium here. So again, in helium now, I'm going to have 2 protons, 2 neutrons, and I have 2 electrons to balance the charge. Okay, so far so good. Let's do the next one. Let's say we go to, now we're going to go to lithium, and this is where it's going to get interesting. So now I have my orbit here for my electron, and I'm actually going to have a second orbit now, because I'm going to be in the second period, and this is going to cause me to have a second shell here. So here's my first 2 electrons, here's my third, and then inside here, and I think I'm going to stop drawing these nucleuses right around this point, but here we have 3 protons and 4 neutrons. 1, 2, 3, 4. So it looks something like that. And as you can see, now this first orbital, every element I draw from here out is going to have this first orbital in the center, and then it's going to have a second orbital after it. But we know that the most electrons, the max number of electrons we're going to have in the first orbital is going to be 2, based on this, and that matches up with our periodic table. If we look at these first 2 elements, this is going to have 1 electron, this is going to have 2 electrons. Okay, now let's look at beryllium. I'm just going to put B here, and I'm going to draw this one a little bit faster, and we're going to skip the nucleus this time. We know that it's there, but just for the sake of time, I'm just going to draw something like this. And what happens here is, as we go down this row, so again we have 1, now we have 2 is going to be here, and as we go down, we're eventually going to get to 8 electrons in that outermost shell. So you can imagine neon is going to look, which is at the end of this row, is going to look something like this. I'm drawing really bad circles, hopefully you can forgive me for that. But neon's going to have 8, 2, 3, 4, 5, 6, 7, 8. So neon's going to have 8 electrons in its shell. When we start to remove electrons, each one of these atoms is going to have a specific arrangement in terms of electrons that it will typically have in terms of it being an ion. So lithium, for example, in a lot of cases, if these atoms all want to be at the max number in the second row, which is 8. And you'll see, if you look on a periodic table, the next row of elements. You're going to have sodium, magnesium, they're going to go all the way down: aluminum, silicon, phosphorus, sulfurous, chlorine, and argon. And again, from every row from here down, and we're going to just pretend we don't see the transition elements here, from every row from here down, we'll see that there's going to be 8 electrons in this last element shell, and there's only 1 in this first element shell. And every single element is going to be kind of chasing these 8 electrons. They're all going to want 8 electrons. And you might have heard of this. This is called the octet. So octet, coming from, if you know what an octagon is, it has 8 sides. So they're all trying to get to this big 8, the big powerful 8 number of electrons. So what happens, going back to lithium, is when you have a lithium atom here, and say we have a fluorine atom over here, the fluorine, which looks something like this, and the lithium, we're going to have something like this. The fluorine is actually quite bigger than the lithium, so I'm not drawing these to scale, but the lithium is going to be like that. And then you have your fluorine here, and fluorine, if we look on our periodic table, it's the 7th element in its row, so it's going to have 7 electrons in this outermost shell. And the fluorine only has to have 1 more electron to get to 8. So it's so close to getting to that very last to getting to this octet that it is very, very hungry for an electron. So this lithium, on the other hand, he still has to get 7 more electrons to get to 8. So he's not really as thrilled about trying to get an electron. So he's more so just trying to get rid of this electron, because then he can get rid of this shell. He wouldn't have to really, the shell's not really going to leave, but he's just not going to have any electrons in it, and he can focus more on this more stable shell, which we know the max number of electrons that you could have in this first shell was 2. That's what we talked about. So he's basically going to resemble helium, which is much more stable because he's reached that max number in the first shell. So again, lithium is going to be more willing to give up this electron. So because of that, when you have an element or a molecule like lithium fluoride, the electron here is actually going to spend most of its time over in the fluorine. So the fluorine can kind of pretend that it has an octet, that it has 8 electrons around it. And for that reason, we would write lithium, the ion at least, the lithium ion. So this is what a lithium atom. We would write a lithium ion with a +1 charge. And sometimes in chemistry, or most of the time, they just write the plus. They leave out the 1. Kind of like in math when you have 1x, you just write x. Same concept. We're leaving out the 1. So fluorine, on the other hand, and again, the reason we write a plus here, let me clarify that for a second. The reason we write a plus here is because it's a slightly positive charge, because this electron is going to be spending its time over here. So when you lose an electron, you're going to get more of a positive charge. And he's not completely losing the electron, but it is going to spend most of its time by the fluorine. Fluorine is going to hog because the fluorine wants this 8, and the lithium doesn't really care. So that this is going to have a positive 1 charge because 1 electron moved over. The fluorine, on the other hand, the fluorine is going to have a -1 charge because it's getting an extra electron over here from this lithium. Or, again, we can just write this as F-. Okay, in the next video we're going to go into a little bit more detail as to what happens with all of these other elements in terms of their ions.